All right, and if you have your pre-act table out, or the paper one that I gave you, or do you have a link on it? Do you have a link on yours for the pre-act table that I gave you guys? Okay, so be able to access that because I'll talk about that as we're going on here. All right, again, elements cannot be broken down into other substances. Elements are the smallest building block that nature's providing to us. And we will do a lot more with elements and compounds and things. This is just, again, it's an introductory type lecture here. An element is the simplest form of matter and has unique set of properties. Each element is unique in its own way, just like you. All right. So when we talk about things like carbon, we're going to find out that carbon has a certain number of protons. It has a certain number of neutrons based on what type of isotope we're looking at, and has a certain number of electrons. But most importantly, the number of protons helps us to identify what we're looking at. Yeah? Just to y'all. I put this box on here, the symbols and Latin names for some of the elements, because as you were learning those yesterday, some of you are like, why does sodium start with Na? Well, before the convention came into play, there were some elements that are already named before chemistry was born. Chemistry has only been around for about 350 years as a subject. Before that, it was alchemy. And the alchemists really worked hard to change lead into gold. We can do that today. It just costs a lot more to do that than the gold is worth after we finish. But some of the Latin names are kind of interesting in how they look that way. But again, that's why we use those symbols. Now, some of you have tried to memorize antimony. There's an easy way to remember how to memorize antimony. Antimony has the symbol SB, right? Okay. So antimony rhymes with alimony. And if you have to pay alimony, you have to pay that son of a... Okay, so that's kind of an easy way to remember that. I've also had some students say, don't put lead in my peanut butter. Okay, so don't put lead in my peanut butter. Also, I've heard some say, it's a sin to tin. Yeah, that was kind of lame, but hey. Oh, and another one that I have, there is no G in gold. There is no G in gold. It's probably a good one to remember. Yeah, there is. It's right there. Yeah, I know. All right. The atoms of a certain element have special affinities. What does affinity mean? Attribute. Anybody know the real reason or real definition of affinity? In other words, I'm sure you all have an affinity for chemistry. It's a love, a desire, an attraction. Yeah. So atoms of a certain element have special affinities for each other. Now, just like you don't necessarily like everybody. Same thing with elements. Elements don't like everybody either, or everything there is. There are certain elements that really love certain types of other elements. That's what makes them attractive to each other. Okay, and then there are certain elements like, whatever, I can do without that, or it, or whatever. So chemistry is life, remember that. A compound always contains atoms of different elements. So you'll hear me use the term molecule and compound. A molecule has two atoms. So like, for example, hydrogen, oxygen, nitrogen. These are how those elements exist when they're by themselves. Those are molecules. Things like sodium chloride, okay, is different than a molecule. Actually, it is a molecule, but it also falls under the definition of a compound because it has at least two different kinds of elements. Where over here, nitrogen is the only thing, oxygen's the only thing, and then hydrogen's the only thing in that molecule. Now, when I first accepted this job, I was really excited by the room number. Does anybody know the significance of the room number?
I don't know. I was going to say that.
So H2O2?
Yeah, hydrogen peroxide.
Hydrogen peroxide. And when you walk in the door over the sign for the room number, I have this structure. It's two oxygen atoms, and then you have a hydrogen and a hydrogen. It's the compound for hydrogen peroxide. So when you get a boo-boo, you can think about this room from now on. Oh. Yeah, again, it's a boo-boo. All right, let's see. So I think I talked about molecule, compound. So let's see. In other words, compounds are molecules, but not all molecules are compounds. So again, by definition, a compound has at least two different elements. A molecule has two atoms, at least two atoms. Could be different, could be the same. All right, the periodic table, a brief introduction. Again, we will, does everybody have the blanks up to this point? Okay. We will spend a lot of time, today is not the day, we will spend a lot of time discussing the periodic table, why it looks the way that it does, why there are two elements in the first row and there's 8 elements in the second, third row, and then there's a whole bunch of elements there, and then we've got these elements down here that are actually in between these elements there. So we'll talk about that a little bit later on. Today's not that day. Today's just an introduction, aka not kindergarten, but junior high type material. But the periodic table is arranged in a particular way for a reason. It's not just by accident or like, that looks good. Let's leave it like that. No. All right. So here are some terms, and they're down here, and I'm going to actually define those for you. When we talk about a period is a row. So it goes horizontal like this. So periods aren't as significant as the vertical component, which are called families or groups. Now, when we talk about families and groups, things like that, group 1A, all those elements within group 1A behave in a similar fashion or similar way. And then if I were to look at, say, the elements in group 2A, they too behave in a similar way. If I go all the way over to the other side and I look at, say, 7A, these are halogens. They behave in a similar way and so on and so forth. So the periodic table is arranged in a really, really nice fashion because they represent what others can do in that column. Now, those 3 elements that I just circled, what are those?
Copper, silver, and gold.
Good, so that's good. Copper, silver, and gold. These are our conductors. In other words, these are very good at conducting electricity. But we use copper to wire our buildings, our houses, and things because it's cheap. However, we could wire our houses with silver and gold, and it would work really well and be really efficient. Actually, in your electronic devices, you do have some gold in there as connectors. So when it's really important, then you actually have some gold wiring in there. All right, so the vertical columns, again, those are called groups or families. And actually, let's see if I have the names below there. Can't remember where I did that. Okay, we'll come back to that. Oh, one other thing. On your periodic table, not this one, I believe there's a stair step that does this. Am I on the right elements?
Yeah.
Something like that. Okay. So where that stair step is represents a difference between metals and nonmetals. All of these are considered metals. And then all of these, to the right of the stair step, these are nonmetals. Okay? So the periodic table is made up mostly of what? Metal. Yeah, there's far more metals than there are nonmetals. But what's kind of cool is with these nonmetals over here, there's a lot that takes place in there. In other words, that's where all the organic chemistry is occurring. Okay. All right, so wanted to throw that in. Let's see. Oh, yeah, chemists use symbols, chemical symbols to represent elements and chemical formulas to represent compounds. So the reason why I'm having you memorize the 52 elements, names, and symbols is because those are the most common that we will use in this class. And they're also the same ones that we'll use in AP. The periodic table allows you to easily compare the properties of one element or group to another element. So we'll be able to look at that as well. That periodic table will be a tool that you'll use and refer to quite a bit. All right, so the periodic table today, I think I added this recently, so you might want to add that in your notes. Metals make up the majority of the periodic table, and again, they're on the left side of that stair step. And if you want to put that stair step in your notes, that's probably not a bad idea. Let me put that stair step there again. So again, metals make up the majority. So again, that stair step goes like this. Okay. So it starts between boron and aluminum and then cascades down. Now, these elements here are considered metalloids. We don't really talk a whole lot about metalloids in here. It's more about the metals and nonmetals. Okay. All right. Chemical families. I want to talk about each one of these four so you can see that, and I don't think there's any blanks on those. So let me talk about the four that we really need to know. So, for example, looking at group 1A, these are called alkali metals. In other words, this is what we make most of our batteries with. In your phone, what kind of battery do you have? A lithium ion. Yeah, so lithium right there. And if you take AP Chemistry, we'll talk about how well that holds electrons, how well it stores them, and then how easily it disperses those electrons. So that's really nice technology for our phone, our electric cars, as we get more and more of those out and about. Looking at group 2A, these are our alkali earth metals. Okay, they're special, I guess. And then come over here, you. And then over here, group 7A, these are our halogens. These are our salt formers. And you'll generally see that with one of these. One of the most common that we're familiar with is sodium with the chlorine. And then this last group represents what? Noble gases. And we'll talk about how stuck up they are later on. Okay. They don't like to dance with anybody. That's all right. Okay. And then the representative elements. Yeah, let's talk about that. Representative elements are the ones that are in the A columns. These are actually what make up our valence electrons. So we'll talk about valence electrons a little bit later on. So those are where the representative elements are at. The transition metals. Transition metals are right here. They're in the middle. And then the bottom two rows actually represent our intertransition. Okay. So you've got representative, transition, intertransition. And I believe that is it. So the homework for tonight, the 11s, and probably the most important one is make sure that you understand or memorize or have been memorizing your 52 elements and agent symbols.